Good evening, everybody. Can you hear me?
Good evening, sir.
Okay. Yes, now we are going to start the session. Today, the main focus of this lesson is to introduce what are the resources of renewable energy. And we are main focus to solar, wind, and hydro, and some sort of other possibilities are there because of presently we have these three resources are commonly using as a commercial viable options. We'll see how we can assess the potential as well as the resources of these renewables. I think when my session, you can disturb me at any time, then I would like to conduct this session as the discussion level. Okay. We know that potential of renewable energy, and the main energy creator is the sun. Again, actually, last time also I little bit introduced that we can go a little bit further by this source of energy. You can see here. Now the solar radiations which come to the earth, then I'm not going to read in these figures there. You can see a large amount of solar radiations are coming there. There is more than 10 to the power of 13 kilowatt hours per year. Like that type of energy sources coming there. Then that source is converted to other source of energy, all the hydropower, biomass, and wave energy also is converted to the solar energy to these sources. We can see the wind energy is the highest one compared to the other one. Then the wind and the wave and biomass and hydropower. Then, however, then our energy requirement is very much less. You can see here how that renewable energy is there, but the conversion possibilities and viabilities and every lot of challenges there. Then even though we have the sufficient amount of renewable energy in the world. Right, then that is scale wise. You can see this figure is give that is scale wise how much of the each source of energy which is in the world. If we go for a solar energy, the solar energy we can use directly without converting to the other source of energy. That is much more convenient sometime. We can see what are the potential of the solar energy. You can see the sun. Sun radiate, that is the 1 to the 10 to the power of 15 kilowatt hours. That is per that actually this per hour. You can see here. Then it almost converted to around 2% to the wind energy. I think that is around 50 to 100 times more than it is converted to the biomass. Biomass is again the solar convert to the biomass by using photosynthesis. Then mainly, actually, we can see about that solar, wind, and biomass. Those are the main the possibilities. Presently, we are discussing in this session. Now, the concept of I'm not going to discuss too much of these things because of these informations are already in the other archive. You can read these things very commonly, but just for how we can see here how that the energy is created by sun. Actually, this fusion, the reaction is coming there. Then it's generate radiations. Then actually this radiations is come to the earth. Then we can see there actually the long time ago that radiations is actually things coming from the earth. It's also convert to the fossil fuel, and that's the way that we have many argument about the fossil. However, the person we can see about the almost all things is coming to the earth by the fusion reactions. This hydrogen is converted to the helium. That's the main point is coming there. That is the renewable energy. Yes. Then we can see here now, if you think about solar solar radiation is directly come to the earth. We can directly converted that solar radiation to useful manner. Actually, the thermal energy, because of we know that the solar thermal generations. Then after the thermal, we can convert to the any source of energy. We can see there how that the thermal energy. Then we know that the solar thermal collectors we can use here. The technology concept we are going to discuss later sessions. However, in the concept wise, you can see here the few type of the solar collectors are there. The concentrated solar collectors, as well as the flat type solar collectors. Then by using this thermal, the thermal energy we can convert to the mechanical energy. Actually, I hope you know that there's a ideal thermal cycle, like the Carnot cycle. Then actually this Carnot cycle efficiency is good. There's around 14 to 50, 40 to 60%. Then I can see here, then by using thermal, we can convert to the mechanical energy, as well as the thermal energy we can use to some sort of other useful manner, maybe a absorption cycle for refrigerations, as well as we can use as it is for a maybe a thermal requirement, such as the water heating, or maybe thermal energy storage, like that type of concept presently we are using, commonly we can use here. However, you can see here there's a conversion efficiency is much more high. This around, you can see here the 35%, the 60%, these type of high range of conversion efficiency. That is the one sort of energy conversions, solar radiation to thermal. Very much useful. Presently, most of the places we can use there, and there are a lot of research work also going on. Then that is very much commonly used as a solar energy. Then other concept is photoelectric energy. Then solar radiation can be directly converted to the electricity. That also the photoelectric concept. Then that is a very commonly used concept in the world, direct conversion of solar to electricity. There are many technology as well as some now presently there are a lot of development in this concept. Actually, the silicon is the commercially the module manufacturing material. However, there are some other material also there. It is around the 20% the maximum conversion efficiency, but I think so in the commercial one maybe much less amount that. But in the renewable energy, concept of renewable energy, we not need much consider about the conversion efficiency, but the most important factor is the cost of energy generations, because of if we can convert that the useful energy by the low cost, then that is the main factor there, even though conversion efficiency is less, because of we have sufficient solar energy most of the places. Only restriction is surface area. If that surface area is the restriction, we need to think about that conversion efficiency. However, the reliability and other all factors need to be considered, the material wise. And we have to think about that other life cycle situations of all these material conversions and recycling. The potential wise, you can see here the solar energy potentials throughout the world. That is small rough map throughout. You can see here. Some countries, they received a higher amount of solar radiations compared to some other countries. You can see here, in compared to Sri Lanka, then some other countries like Australia, Africa, as well as the South and the North America. Some places, they receive high amount of solar radiations. And that's the idea we need to discuss here. Even though we are in the equator, then we have comparatively, some other places have much more solar radiations because of some other factors. We can discuss these things later. Because of the solar map is important if we go for a solar energy conversion technologies. In Sri Lanka also we can see here, just map like that. That's solar radiation map. This is the global horizontal irradiations in Sri Lanka. You can see here. Then that is uh, per square meter values are given there. This map was published by the SEA. You can see here some places of Sri Lanka much less compared to some places. However, the comparatively is a 1,250 to around 2,100, like that type of ranges are there. There is a per day the kilowatt hours energy. Now, some important parameters we can discuss here. That is irradiance and radiations. Irradiance is given by watt per square meter. It is a symbol of G. Actually, there's an energy per unit surface area. Then there's the power and energy. You can see the radiation is the energy. That's the amount of energy. That is amount of energy. This joule per square meter. Then some time limit should be defined. Usually, it may be hour or per day. The per day, how much of energy received per square meter, as well as it can give what per square meter mean is a time wise. That mean that's instantaneous power. Actually, that also important because of what per square meter may be. We need to give per each time per particular day. That means joule per square meter should be per day wise the total amount of energy receive that particular places. Then we have to we need these two parameters. Then actually insolations is term of use solar energy radiations, and radiosity also now some other terms here. The rate of there's a rate at which radiant energy leaves surface per unit area. Actually, that is combined by this reflection, emission, as well as the transmission. We can discuss these things when for the slides. In actually, for when we need to discuss these things, Earth-Sun relationship is very much important to understand. Then the solar constant is one of the parameter. Actually, sun, the sun is here. You can see the sun, the sun is here. Then it emits such amount of solar energy. Then actually the Earth position is there. You can see here now the sun emit these radiations. The Earth is there. How much of energy received on this point? That's we are calling this a solar constant. The solar constant is depend on, because you can see here there's an angle is important. There's a 32 degrees. Then this angle is totally depend on what's the distance between sun and Earth. If we take this distance 1.495 into the 10 to the power of 11 meters, then it is not a constant value. It's changed time to time. Then this solar constant also change time to time. You can see here now, if that the mean value, you can see here, if that the length is like that in this level, that a solar constant can be defined 1,367 watt per square meter. then that amount of radiation we receive the uppermost atmosphere. That's the point here, that the uppermost atmosphere, that amount of radiation is received. If the distance is that much. However, each day of the year, this distance is varied because of the Earth movement the orbit is somewhat um, elliptical orbit. Then the distance between the Sun and Earth varied from time to time. Then the solar constant also varied time to time. Then we need to define the solar constant each day of the year. Now, I hope you can understand what is the solar constancy here, then the amount of radiation at uppermost atmosphere. Now, we can see how, however, in the actual radiation what we receive in the surface area of the Earth is not a solar constant. There are some other effects in between in our atmospheric transmission from uppermost atmosphere to Earth's surface. We know that some amount of radiation can be absorbed by the aerosol and this atmospheric material, as well as the reflections also there. Then this amount of we receive in the Earth's surface is depend on atmospheric conditions. Now you can understand that even though we have the constant solar constant, but the location-wise difference between due to this effect, maybe the atmospheric conditions and other ground effect may be the main reasons. You can see here in the Sri Lanka also some places we receive high amount of solar radiation compared to the other places because of atmospheric conditions are not the same throughout the island. We can see then other point here I already explained that because of that Earth-Sun relationship, the R is the change time to time. So R is that actual R is that is the distance between Earth and Sun on the day of the year. Actually, that is depend on the day. We can, because this is elliptical orbit there, we can just define some empirical equations for the orbit of Earth around the Sun. Then this is the equation. You can see here the ratio between R average into real value. Then this B is the day of the year. Then now each day we know each day because of the from starting from January, then we can calculate the the solar constant in a particular day. Now this is the average amount. However, we can calculate the actual solar constant. The solar constant is the meaning of the solar constant. So Earth is there. In some place here, how much of energy received that is from the sun. We are not going to discuss these things because of there is atmospheric effect later, right? Now, if we go for a next slide, now this is a way through the atmosphere. You can see here that is extraterrestrial irradiance. We are calling solar constant 1367 watt per square meter. Then it's passing through that atmosphere. For the atmosphere, you can see here there's ozone, air molecules, aerosol, cloud, water vapor. Those are the main element between uppermost atmosphere to the Earth's surface. In some amount of absorptions, you can see here that some amount of energy can be absorbed. We know that actually the greenhouse effect gases also we can discuss further. Then that's different because of how much of energy absorbed by these gases throughout this pathway. Now, These are the two things. It's a direct horizontal irradiance and diffusion. You can see this is some small equation we can find out there. Actually, this is the equation we can here. There is find out there. The diffusion is there. The diffusion as the direct one. Global horizontal irradiance is the important parameter for photovoltaic sometimes because of it can absorb direct as well as diffusion both. If you give some example like that, because of some example like that, direct horizontal irradiation 600 watt per square meter, and the diffusion is 1,150 watt per square meter. Then global horizontal one is 750. We can see that the diffusion is depend on what are the element around. Maybe sometimes the buildings and other geometrical other geometrical object also very much effective to how much of the diffusion light is there. You can see here. Even though you can see here after the sunset, we have some amount of light. We know that after the sunset as well as that is sunrise also. We can see this that is the effect of the diffusion. The diffusion effect is there even though the sun is ahead for us. So this global horizontal radiance should be calculated by the direct plus the diffusion both. That need to be understand. Now, I already a little bit explained that what are the situation of these things we can see here. Now, each and every month, especially in the December and here's some small question is there actually the direct horizontal mean actually here that is horizontal meaning of that line between sun and earth. We are consider that's a horizontal line, and the radiations coming directly from sun to earth. That's the point here. Actually, for a solar panel can be absorbed not only that radiation, the diffusion also can be absorbed. You can see here, we know that sometimes some of, as for example, some small solar panel, we have our some calculators, it can generate a small amount of energy without direct sunlight. The diffusion can also helpful to generate small amount of energy. Right. You can see here now. This is the Earth Sun relationship. That is important. That because of that, the inclination of Earth is very much important. That is 23.5. Also, there you can see here now the solar radiation is received. That effect also need to be considered. Now this is the December and June. It is these 2 points as well as the March as well as in September. In these 2 points are there in the very much closer points as well as the highest the peak points. The 2 points are there. Now it's the south and north, and north regions. You can see here some seasons also happening due to that this inclination of the Earth. Because of that, if that season the North Pole is another hemisphere, they may receive the higher amount of solar radiation that is seasonal wise due to that inclinations. But in Sri Lanka, it's not much important to us. Then the similar explanation we can give here in the top in the projection views. You can see here in the North Pole, the location of the North Poles you can see there. Then at that point, it receives high amount of solar radiation. In this level, it receives less amount of solar radiations. However, I'll go to this point. You can see here now in this inclination one that solar that solar receive angle also change time to time. This is a mean. This is a mean angle, which you can see here. Then this is the variation of that angle. We are called the declination angle. This declination angle is depend on the month wise. You can see in the March and April there is 0 because you can see the month March and December it is 0. You can see in I think you can see here because of there are no any. It is almost in the same the half of the Earth receive that solar radiation, and here also it is half of this Earth is received solar radiation if the line is across that polar. But here, if the line across the polar angle is not like that, you can see that is we are calling the declination angle. This declination angle is changed by it is minus in January. It is again the plus in like in June, it is 23 point, like that point here, that is the value there. Then that angle also calculated the day of the year. This equation is given there. Again, it also due to that inclination angle. And I'll give one good point there. Shall we think, if you want to solar tracker, the solar tracker, we need to consider this one because you can see each and every month, you can see this a day. Actually, the day wise, when we consider day, we need to track by our solar tracker from east to west, changing by with the time, as well as we can say it need to be little bit declination each every month. You can see in the January we need to little bit change is the minus that mean minus mean it should be to the south direction. Then this type of the variation should be there. That mean there's a 2-axis the solar tracker need to be considered because of that declination angle as well as the time of the day. What do you think about that? If we have the fixed solar panel, yes, no problem actually. If we consider then a fixed solar panel, then this declination angle throughout the year, it is mean of the zero. Then we not need to consider that if we go for the mean value of the year, it is 0. But we need to consider to install a solar panel by considering the latitude point. That means if you think that if you're going to install a solar panel in Hambantota, then our angle is not same. It is we are going to install a solar panel in the Jaffna because of latitude angle we need to consider very seriously. It's not like it shall be think if you're going to install a solar panel in the Europe, this is a different angle. Then that is a geographical location is the important when we're going to install a solar panel at the point of the Earth because of the solar radiation is received. You can see here now. Let's see, and then if we think about that. When we're going to install a solar panel in this location, because of saluting, sun is coming to that direction, it should be that angle. If you're going to install a solar panel in this location, it should be that angle. You see now this angle between the surface of the Earth. This is the angle there. This is the angle there. Then angle is changed. If you're going to shall we going to install angle solar panel the equator, that the angle should be 0. Then but that declination angle can be neglected because of the throughout the year there's an average angle throughout the year is 0. But if you're going to think about solar tracker, that variation should be considered. Yes, this is the point. Again, I explained that because of that inclination. This is the point what I already explained in my last slide. You can see here. Now, there's a different way. You can see here the beam is coming there. Then the surface area of the beam is different. Then you can see here, there's the energy received from each location is different because of that solar radiation is received. We are calling the sun angle. Now, I little bit explain about these things again because of that the main effect is coming there because of the main receive point is we are calling solar constant 1367. This is a mean value. For real value, you need to calculate the day of the day that the previous equation you can use here. Shall we take that is the average value. Now the cloud and some sort of that reflected solar radiations. Then here the solar radiation at the sea level is 1000 watt per square meter. That's for example, you can see here, if the 1367 is received, then however, the G is the value there, then it is around 1000 watt per square meter. This depends on location. The solar map is need to be developed there. Actually, there's a lot of models are coming there. This is satellite development model. By using satellite images, we can calculate amount of the material, that means condition of the air between atmosphere, the uppermost atmosphere, the earth. Then that material can be estimated. Then we can roughly model how much of energy absorbed as well as the reflect by using this material. Then we can calculate solar radiation at sea level. That's the way these solar maps are developed, and the radiation maps develop each and every day. Because of these type of models are already there because of already there. This is one example in the solar radiations. You can see here. Can see here that is 7 p.m. It is almost zero, as well as around the 5:30 is almost zero. This depend on the Earth locations because of if you go for a north, northern hemisphere, southern hemisphere, some period they may have the longer day. Then that's depend. That means longer day mean maybe a very early morning the sunrise as well as very late sunset. Then they may receive the high amount of solar radiations. Here we can see the real values are there. You can see it's not a smooth curve here because of the cloud cover. Because of the cloud cover variations are very much varied throughout the day. That is very much important for energy generation. Presently, also we know that sometime for this cloud cover, very quickly within few seconds, it cover almost the sun. It reduce that energy level, maybe half as well as very low level. That also challenging for the solar energy because of the constant or steady power generation cannot be guaranteed sometime because of the depend on the cloud cover. How we can, this is one of the example. However, it is not the big one. However, some places the huge drops we can observe time to time. Now, the few examples. Actually, you can download these type of maps in solar map. This global solar map is already there. There's open source now. However, you can see here this direct normal and global horizontal one is coming there. You can see here there's a 5,000 is a maximum. Some places we may receive a high amount of the 5,000 watt hour per square meter per day. Then a small introduction for technology. Then it's a parabolic disk configuration. We are going to discuss these things later very deeply. Presently, just as an introduction. Then this receiver is there, absorber tube is there. This absorber tube mean again here is the absorber tube. Yes, maybe a water tube. It can be generated steam here. And we can use some other fluid for heat transfer. Maybe if some technology have thermal energy storage, Then thermic fluid we can use to transfer heat to that thermal energy storage point. This parabolic mirrors are there. Then it reflect that energy for this point. It can generate very high temperature, very high temperature. Actually, we know that if we have very high temperature, this can be used for, it can be used for power generation. There are some drawback also there. If we use very high temperature, the heat loss also high, then we need to consider what is the optimum temperature level for power generation. We can, then actually the heat transfer is the important point here, how much of the fluid flow through this absorber tube. Then this is also the one of the concept here. There is a central receiver there. It's a tower type receiver. These type of reflectors are coming around this point. These drawbacks and everything is coming there because of, you can see it, some shadow effect is coming there, this type of point. However, it can be generate high temperature by using power tower configurations. This also common configuration. There's a reflector type, there's a parabolic reflector type, as well as this is the other configuration. And this absorber tube is almost each and every parabolic collectors in the center of the parabolic collectors. That also one concept that is much more convenient configuration compared to this configuration. I hope we not need to discuss these things too very deeply, because of you all can get this information very clearly. However, this is also one other concept, because of the thermal storage systems are very much commonly used, very much important to use here, because of we know that the solar energy is not consistent, as well as it receives only daytime. You can see here the last configuration we observed that it's starting from 7, then it's at its end 5 p.m. and the higher may be received in between that, maybe 10 to 3 p.m. like that type of period we can receive the solar energy. Then, but our demand is not like that. It is throughout the day. Then if we need to run the systems for the solar energy, then we need some thermal storage mechanism. And this is one concept here. There's a solar, the field there. It can be store some solar energy can be stored as a thermal energy storage. Personally, there are many technologies there, like this space change material. We know that latent heat can be stored high amount of energy compared to sensible heat. Then the phase change material may be gassed to liquid. This type of the conversion, the phase change material we can use here. Then that's a material type is depend on the temperature requirement. A lot of mixture of thermal storage liquids are there. I am not going to discuss these things. We can discuss later. What are the thermal energy storage materials? However, the thermal energy storage system we can see here, it can be store some amount of energy here. Then again, we can use this type of steam turbine. Yes, obviously, this optional boiler may be there because of that. Always the renewable energy is not consistent, but our required the demand is we need to fulfill throughout the day. Then is almost the hybrid system. The most commonly the hybrid systems are commonly used there. Actually, we can think about that the absorption cycle for the refrigeration, solar, refrigeration systems with some hybrid thermal supply. That also one concept, how to utilize solar energy as it is. Actually, this is the one of the advantage of this type of system is to be little bit large systems. There's large systems. However, this conversion efficiency is much more high compared to the solar photovoltaic because of that Carnot cycle efficiency can be applied here. Now, that is the common system. I hope you all know that the photovoltaic one, that is much more convenient. It can directly convert solar to grid electricity. It's presently commercially, these type of systems are very much commonly used, these things. I think for a solar wise, I give the brief idea about the solar resources as well as some concept of the technologies. We are not going to discuss very deeply what are the technological concept. Then we can cover these things somewhat in later session because of this lesson is introduction to renewable energy. Right. The main is I already explained that today we are going to a little bit to talk about the hydropower also. In the context of the Sri Lankan situation, we have some sort of hydropower because of we have the mountains area, the high elevation. That potential energy can be converted to kinetic energy by using the hydropower system. The potential energy means again the water. The water in the higher lands we can make some arrangement to come down, then that potential energy can be converted to the kinetic energy. It can be used as a mechanical conversion, can be used there. Then that's the main concept of the hydropower. The hydropower resources, we can say the hydropower resources wise, those are the main areas, main district we can discuss because of the highlands area. Yes, because of can see here the present the potential wise is give some resource assessments previously conducted. You can see here but the presently we can see the hydropower development in Sri Lankan situation. We already utilize almost all places. Maybe some small places are there. Now the hydropower is almost utilized in Sri Lanka situations because of yes, some sites are there still, but we need to consider a lot of environmental impact and socio-environmental impact. Those are the main factors. Presently, we are facing to develop these existing sites. Now, the main concept of that hydropower, I'm not going to deeply discuss that because of that. It's upper reservoir here, it's a dam, maybe small dam. Actually, for large hydro, we need a dam there, but in the micro and small mini hydro, we not require a dam there. We can use water as it is without any storage. Then here there's a potential energy. We can it's come through the penstock. We are calling the penstock is the main item. It converts to potential to kinetic energy. Then here there's a power station. There's a turbine is operating there. The type of the turbine depend on the location, head and the flow rate. We can discuss this turbine type later. However, turbine is the equipment. Pelton wheel, Francis wheel. There are many types of turbines are there. Then this turbine is the equipment. It convert to mechanical energy. Then you can see here there are potential energies there. Then ultimately it convert to the kinetic energy. That means it's the high velocity of the water here. There is a tail race. That means that exit water has not much velocity, almost zero. That all energy can be converted to mechanical energy. We know that if we have the mechanical energy, it can be converted to the electricity by using the generators. That's the main idea to the hydropower concept. For a hydropower potentials, simple idea. Actually, the catchment is the important point here. Is the catchment is, shall we think, the geographical situation, then then it's a line. We can draw the same height line there. Then we calling that there's a catchment area. The one example, shall we think this is a hilly area there. For a These gutters, this a catchment area is this roof area like that. Like that is similar way. The flow of the rainwater, it's a rainwater. It's a rainwater, receive this rainwater in this land area. Then if we know the rainfall of the particular locations and we know the catchment area of that river or streams, we can calculate how much of water reserve for that catchment area. Then yes, some losses are there because of the groundwater as well as the water can be other losses. Then however, this catchment is the important point when we consider the potential of that hydropower station. The higher catchment and maybe higher uh, amount of water. Then as rainfall also important because the rainfall, some locations where the higher rainfall and the catchment, then we can calculate what amount of the flow rate is coming to that stream. Then the head obviously calculated. Head, if we know the head and the flow rate, we can calculate the amount of energy of that potential area. Actually, the power is the equation. This is simple equations. That is the amount of the water is coming through that stream. This cubic meters per second shall we take that this unit we can calculate here, as well as the amount of the head is there. That head mean from here to that point we are calling this head. Head is there. Actually, this is gross head, the net head with losses and everything. This is the net head. Actually, it's a penstock from the penstock starting point to the end point. We are calling this the head is coming the flow rate. Obviously, we know. Conversion efficiency we can calculate here. Maybe this efficiencies consist of that conventional losses of the penstock as well as the turbine and generator. Then this is the efficiency. The power generation, amount of power generation we can calculate if we know the site location. There's a flow rate and head is there. Then actually, if you already visited that the Learnify one, there is one tool is there to calculate each and every locations how much of the flow rate and head in Sri Lanka. Then I think that's maybe interest tool in generate of that Global Atlas IRENE, this organization. Please visit that Learnify slides. That is already in the Moodle, I think so. Please visit these things. You can understand how much of the hydro potential in Sri Lanka. Now, shall we little bit discuss about that global atmospheric circulations? That may be a little bit interest about you, how I can explain that. There's a global atmospheric circulations also, again, due to solar radiations. Then that insolations variability with the latitude, you can see here. Then some sun rays, the beam size. Shall we take the equal beam size? Then, however, the large area in the northern hemisphere compared to the equator region, you can say that a small area. Then energy intensity is high in equator area compared to the southern or northern places. Then due to that, you can see the energy reserve. That means energy intensity to the globe is not equal that the shape of the because of the shape of the Earth. Then what happened that also very much the important things, the temperature variations. That's the temperature variations is like that. This is one example you can see here. The temperature of that the polar region is much less compared to the equator region because of that the energy reserve, that energy intensity is changed. Actually, it's a monthly wise variation also there due to that inclination angle I already explained previously. Because of that monthly wise variation also we can observe here. However, this global circulations due to this effect because of the monthly wise variations, that means radiations received to the Earth the one point is change monthly wise. That means a time, the day of the year, as well as location wise. The location wise, both things need to be considered. Now, why this a global radiation? Why that global circulations? That means air circulation throughout the Earth. Because of that, the pressure gradients is the main driving force. The one of the main driving force. The main driving force is the pressure gradients. We know that the pressure is depend on density of that air mass. We know that some air column is there. Then here that high temperature points that the pressure is less compared to the low temperature points. Now, actually wind pattern, then we try to understand what are how the wind patterns, the wind motions throughout the earth there. I already explained that the heating is not even, that is uneven heat, as well as geographical location, that geographical topology also we need to consider mountains and other things, maybe sea, the water bodies. There are a lot of effects also there because of the temperature variations are depend on the many other effect, especially the locations as well as the topology topology of the earth. Then if we consider very small scale places, even that the solar heating is the pocket wise, the low pressure, and that the air is warmed and expand and rises because of that the chimney effect is coming there, because of some hot points are coming there. Then the air can be going upward. It generates some low pressure points here. It looks like that because of this. We think if we have that type of idea, you can see here some hot point is there, then it is already this buoyancy effect is going up there. Then you can see here that is the point here. That is a global radiations can be happening. There's global circulations can be happening. Because of that, air can be moved to that locations like this type of, actually there's a main driving force is the pressure gradients. But the direction of the wind is not like that. It is a very much important. We are going to explain that why that the wind is blowing due to that pressure gradient, but that the direction is not true that the pressure gradients. Wind is not moving high pressure to low pressure point. Then some other effect is there. I'm going to explain that. Even though the main driving force is the pressure gradient, the wind is not moving from high pressure to low pressure points. Yes, this is one example. Actually, then if we consider some high pressure and low pressure, this is the main driving force. We are calling the pressure gradient. But we can observe that wind is moving the perpendicular to the pressure gradient. This is a high pressure point is here. There's a high pressure point is there. This low pressure point is there. But wind is moving perpendicular to that pressure gradient line. And we can observe that in the global circulations pattern, there is the one phenomena we are calling that a Coriolis effect. We can see here that some isobar lines throughout the year, throughout the world, we are calling isobar lines. We can observe that. Please wait. Shall I go to that point quickly and come to this point? Come again. If you go to the present situation, there's some weather channel. If you go this type of weather channel, think why that weather channel. So I need to share this again. Yes. Okay, you can see this is the weather channel. It gives that some data. Actually, now in Sri Lanka, is not much the pressure gradients are observed. You can see the 1007, 1008 is a millibar, I think. So the unit is millibar. Shall we little bit go little bit higher point in the earth there? You can see here now. This is the point here now. Actually, those are the pressure gradient. You can see this line is the 1007. No, this is 1007. This line is 1006. Like that. You can see here. Now, those are the isobar lines. Those are the isobar lines. This is the pressure gradient. This you can see this is 1006, 1007, this is 1008, this millibars. Then if the wind is blowing from high pressure to low pressure, the wind should be blow from this direction, no? From this direction. The wind should be blow from this direction. Because of this is high pressure, this is low pressure. The wind should be blow from high pressure to low pressure. But this wind is blowing aligned with the isobar lines. Right? This wind is blowing aligned with that isobar lines. There's a phenomena in the earth because of the wind cannot blow from high pressure to low pressure. Because of that, due to that, other effect is due to the earth rotation. Actually, we are calling this a Coriolis effect. Then that is very much important one. All these global circulations are due to that effect. Even though the main driving force is the pressure gradient, but the wind pattern and other things are effect of this one. This is the present situation in the earth. This is the present situation in the earth. You can see in the Sri Lanka also we can observe that those are the isobar lines. Those are the isobar lines. The wind is blowing through at that line, right? Are there any low pressure stops? There are no any spot now presently. Right, right, okay. Yes, then you said that the pressure gradient is high, wind speed is high. That is correct. Because of the main driving force, the energy is coming from that pressure gradient. Because of the main driving force is coming from the pressure gradient. But the direction is, I'll explain that why that direction is coming there. Higher pressure gradients give the high driving force. That's the wind speed is high. Right? Okay, we can move again to this point again. You can see now. Now, if we not consider Earth rotations, that means if we not consider the Coriolis effect, global circulation should be like that. This is because of that. Because of here. Here in these locations, high temperature zones. There's a low pressure zones. The air can be going upward in this location due to that temperature levels. It will move to that area again. It's a cold air can be come to that low pressure. It is cancelling. This should be the way it should be without Coriolis effect, without Earth rotation. There's a non-rotating Earth, non-rotating Earth. This is the global circulation model, but it's not like that because of that the Coriolis effect is coming there. The Coriolis effect is always there's a perpendicular to the motion. Coriolis force is perpendicular to the motion. Then the pressure gradients, it's move that particle. There's a moving speed is depend on the pressure gradient. As the last questions also I explained that this main driving force. Higher pressure gradients, higher velocity. But that higher velocity, the Coriolis force also high because of the Coriolis force also depend on the velocity and how the all things is coming there. Then what you can see, the resultant path is like that. Because of it, not from high to low, it should be go some other path is there. Then you can see in another hemisphere direction and the southern hemisphere. This is the two directions. So one equation is not coming here. This better. This bit provide. Wait, provide.
Art and craft देखिए.
Yeah. Now you can see this is the equation right here. So it not that equation is not coming to when I go for the presentation mode there. Please wait, I can write here that equation for a Coriolis. There's a Coriolis effect. Please unmute your mic. Mute your mic. Is equal. Why it not clear? No. Shall I write it clearly? Two omega b sine phi. Actually, this is the Coriolis effect equation. There is a yes. Now I can see this is the Coriolis effect equation because of my presentation mode. This equation is maybe the color difference is there. However, the f we can write in this equation. There is a rotational speed of the Earth is omega. Then b is the wind speed. Phi is the latitude angle. We know that shell within this latitude angle, the equator is 0. The North Pole is a 90 degrees. You know that, but it's latitude angle. The Coriolis force, we can write this equation. F is equal. You can see actually, this is a vector that we can consider as a two vector. Wind speed and earth rotation are the two vectors. Then is a vector, is a cross product. We can come in there. Sine phi is the reason here, because the sine phi is coming there. Now I can now can see here, at a higher wind speed, Coriolis force also high. At high wind speed, Coriolis force also high. We know that omega is constant. The rotational speed of the Earth is constant. Phi angle is very much important. The phi angle is very much important. Then we have the less Coriolis force near the equator, high Coriolis force at the one there. Yes, there's the M also there. No, sorry about that. There's M also there. Right, shall I write this again? Because of I can see that yeah, is yeah, that M also there. There's M. There's a mass. This is sine phi, right? There's a mass also there, right? Okay. Now that Coriolis force is we can calculate here, but here there's the important point is phi. Now, now we can understand the Coriolis force effect throughout the globe. Shall I explain that some sort of equations? Yes, there is an equation is coming again. Shall I remove that equation here? Yes, again, actually, this equation should be there, but it's not appear in this slide. That's the equation. Yeah. Now you can see here. Actually, this Coriolis force is due to rotation of the Earth. If we go for a Newtonian mechanics, we can understand that that one. Now we can see here now, due to that Coriolis force, I explained a little bit in some other slide here. Now, actually, I already explained there. This shall I come to this point again? Yes, now we know that it's a high pressure to low pressure. It should be moved like that way. That can move like that. That is move. There's a movement. It should be like that way. Now, after this distance, the distance is almost into that direction. Because it cannot, the wind cannot move further to south or near the equator, south. Then again, this situation we can define few cycles. That means 1, 2, 3 cycles are there. That means 3 cycles we can observe there. There's it gives the polar crystallines as well as the Bester lines, and here is the equator. In the 3 cycles are we can observe because of 3 cycles are happening due to Coriolis force. Without Coriolis force, only there's 1 cycle, what I explained previously. Without Coriolis force, there is only 1 cycle. That is only 1 cycle. Due to that Coriolis force, there's come only 3 cycles are coming there. You can see here now. Earth, that atmospheric height, that means amount of air layer near the equator is little bit high compared to the equator because of the centrifugal force of this air is much more to that equator level. Then the air is thin in the polar region. The air is little bit higher thick in our equator regions. That may be the reason. You can see here some the ultraviolet also a little bit less compared to the polar region is high compared to the equator because of it need to be passed through the higher mass of air need to be passed through in the radiation in the equator region compared to the polar region. However, we can understand that there are three cycles are coming there. There are three cycles are coming there. These three cycles you can see here. I'll explain again what are these three cycles you can see here. Now, shall I explain like this cycle first? You can see now the hot air is going up there. Hot air is going up there. Now it is circulation like that. Again, here it is coming here. Now you can see here, this is the surface, near surface wind is blowing to that area. This is the wind we require for a wind energy generation. Very much uppermost layer wind is returned back. It is very much higher level. We cannot reach that level. All wind turbines, we absorb this potential of wind. Now it's going up, it's going down. You can see here in this region, it's receive the same, this cycle and as well as this cycle is that receive the wind there. Now you can see here, we know we have a high amount of rainfall in this area, this equator area. We know that the wind is coming through the ocean. It contains high amount of moisture because of the wind is blowing through the surface. The high amount of moisture, we receive high amount of rainfall in this in this equator in this line. Similar way, you can see here in this region. It is a very much dry air because dry air is received from uppermost area. Then did you notice that these two lines, not all desert areas are in this 30 degrees line. Then this is the 30 degrees line. This all Sahara and all those things, as well as in the Australia also there are the two lines. We can explain these things also by using these global circulations. However, I hope you can have some good idea about that, how that the Coriolis effects effect on these things. Now, shall I little bit move again furthermore? You can see here, this is the global circulation model if we consider Coriolis effect and pressure gradient. But it's not like that, no, because of some other, the topology also come in there, but the real situation is there. Actually, the one idea here, you know that when the Coriolis is find that one. Actually, the wind map developed. Actually, it's not wind map. We can say here the trade wind map. Some of you know about that. Trade wind map. Trade wind map was used at that time for sailors. Sailors use the trade wind map, the seasonal trade wind map, to find their pathway for sailing. Especially we know that European sailors to Indian Ocean. Then they use that as the trade wind map, by the seasonal trade wind map, to select their path as well as the season. Then the person in the Coriolis is a Portuguese person. Then he find out that the wind has some different forces applied top of that rather than the pressure gradient. Then that's the point. The Coriolis is the main person who find out the Coriolis. And he developed the trade wind map. Then you can see now the trade wind map also maybe used that type of concept at that time. Then you can see the real situation is not like that because of that mountains, sea and everything is coming there. However, it's almost due to that Coriolis effect and topology and everything is coming here. Now again, I would explain that why the wind is blowing aligned with the pressure gradient. I always explaining that. Now we can very clearly understand that if we have the low pressure area, if we have the high pressure area, if you have the high pressure area, the wind cannot be moved to that one. The low pressure cannot be cancelling. The cyclones are happening due to that reason. Otherwise, the low pressure and high pressure, then if there are no any Coriolis effect, very quickly it is cancelling out. The wind can be blown from high pressure to low pressure, quickly cancelling out. But now the wind cannot be blown to that area. Wind is rotating like that way. That's the reason that the cyclones is happening due to the Coriolis force. Somebody asked that the wind direction is reverse to subtropical force. We need to go back again that point, no? That is due to, you can see here, now that shall start from the equator. When we start from the equator, there should be this type of rotation is coming there. Then there's a main driving force, it will go this way. However, it not reach to that point, it will ultimately end up this line because of it bending. Because the driving force is main one, it's circular. That also ending, and because it cannot be moved, that cannot be moved from here to there. Right. Now, yes. Now, I think we can explain that the circulations because of the cyclones are happening here. Now, furthermore, shall we go a little further? I already explained this one. Yes, that was very much interesting. The rotational direction, actually, if you go for a northern hemisphere, all cyclones are the counterclockwise. If you go for a southern hemisphere, it is all cyclones are the clockwise because of that. The direction of that Coriolis force is different. There's a Coriolis force is different. There's a in anti-clockwise direction in the northern hemisphere. And that was a one direction. I already explained that why that geographic. Actually, we are calling geostrophic wind. The geostrophic wind is the way is almost the perpendicular to pressure gradient because of if the can see here now here from here actually I can explain a little bit again from there. Shall we now the pressure gradient is there. It is moving like that with some velocity. If the velocity is high, the Coriolis force is high. It is bending again. After some saturation point is coming there, the force due to pressure gradient is equal to the force due to Coriolis force. Then it's a balancing, the wind is blowing to that direction. Yes, that is I already explained that the low pressure and the high pressure. The air cannot be come to the low pressure from high pressure due to the Coriolis force. The cyclone is coming there. Did you notice that there are no any cyclones in equator? Actually, we can say that the -5 and the +5, that with that band, there are no any cyclones. Did you notice that very recent the cyclones, the depression developed in near India, in Sri Lanka and India, I think the last November. If that the depression is moved to northern direction, it is strengthened and strengthened. Then if it is depression is moved to near to the equator, it is cancelling out because of the Coriolis force is less and less due to that phi angle. Then generally the no cyclones are in between -5 and +5, but in Sri Lanka is little bit above that point behind the, I think Hampantara is 6, I think so. Yes, I think this is the point here that the Coriolis force is effect not only wind, aircraft, the train, and every ballistic missile and everything. If you target, if you need to be considered that the Coriolis force, the deviation need to be considered. Then it's a different story. Then, however, that each and every movement in the Earth, the high scale movement, then we need to consider that the Coriolis force. If it is the equator, no problem. If going to the higher point, we have to consider that the Coriolis force for these things. Then if we go for an aircraft in this point, we need to consider some of the extra force is applied on top of that. Some places in some railway track also they can notice that the one rail may be the wear and tear may be high compared to the other line. Because of that the train is applied the Coriolis force to one directions. If the train is moving to one direction always, that happening. Is that also I already explained that then there's a narrowing point here. However, as the wind is very important to consider this all those things. All those things, right? Actually, I already explained this also, why the deserts is happening in these two areas. Why the desert is happening in these two areas in this because of that wind global. Then local wind is different. Then I already explained that the global wind, the local wind also different because of the locally the wind can be generated due to the local effect. We know that the ocean and land temperature difference of the very small areas as well as the mountain areas also the wind can be generated. But for a large scale, but for large scale wind turbines, the local wind may be not much considered because of it is not much strength and large potential. Then we have to consider the global wind conditions. However, if we go for a small scale point, this local wind situation can be considered, as well as there's a locally effect also need to be considered and think about that. Because of it is not any global circulations, and you can see here sometime in that near the mountain also it generate wind as well as those are we are calling local wind conditions. We know that near the sea we have the good wind potential. The direction also change due to day and night due to the temperature variation of the water and land mass. And then in the situation in Sri Lanka, we are affected to the monsoon wind. Because the monsoon wind, we are near the equator, then the sun is up, going to south and north in seasonal wise. Then if the wind is generating due to that motion also, we are calling that there is a monsoon wind. Then we have the intermonsoon period also, obviously sometime in the August as well as the April, near that there's an intermonsoon. Then we have very less wind potential in these two seasons. Then in the wind potential wise, the location in Sri Lanka is not good because of the throughout the year we have not a continuous wind potential due to that the seasonal wind variation. But some countries, they may receive the very good wind potential throughout the year. Then that also need to be considered when we go for a wind energy generation. Yes, this is the seasonal wind. You can see then we have the two seasons, southwest monsoon and the northeast monsoon. Then actually those are the main point what I need to discuss. Please wait. These slides may be not useful to you. If we go for a wind map in Sri Lanka, if you go for a wind map in Sri Lanka, you can see here, actually this is the map I just take that global wind atlas. I think you also can be used this global wind atlas. This is a model. There's a model. There's open platform. You can take that one. There's already validated some the ground data. I think our closest point of this validated point is the Maldives. There's a validated data. I checked that. We can use that as a maybe somewhat good validation resources. You see, if you go for a Sri Lankan wind condition, we can take a good idea about that wind potential. Wind potential of these locations, and this location is somewhat high. This is high potential. This is a high potential. Then if we go for a high large scale wind turbines, we should consider these location because of energy generation due to energy. We need some energy. Why these two locations are very much high? We can explain that. Wind is coming from that direction. There's a southwest monsoon. Actually, wind is coming from that direction. So northeast monsoon. There's a two. So northeast monsoon. There's a southwest monsoon. We have that mountain region in this area. Some sort of mountain region in this area. Actually, this is the mountain region. And from you can see here to here, it's very much the distance wise, maybe the 50 kilometer, very less. Then this is the mountain. Wind is coming there, wind is going up. This is the way. And here around 50 kilometer. That's a region we have not been in that area due to mountains. Due to the mountain, wind is going up. You can see the high amount of wind potential in this mountain region also. I think you can understand that why we have not good wind potential in this Colombo area, as well as the behind that mountains in up to Madakalapu. That area we have not been, there's a good wind potential we have not. Then after the mountain again is a Hampamtur region, also very good wind potential. However, in these points we have very good wind potential in the, actually this is a tunnel between India and Sri Lanka. Wind is coming, the wind is coming from there. This tunneling effect is coming. You can see here also very good wind potential in India because of the wind is diverted from this point. Then it is directly attacked to that Manna Bay. However, it is moving there. That's the main the phenomena we can hear by this the Sri Lankan wind conditions. Why that we have the very good wind potential near that Manna and the Hambandra also somewhat compared to the Manna. That pathway in between Sri Lanka and India is a high wind potential. India also they have the very large amount of wind power generation in this area. In this area, we also have the very good potential in this area. Even though we have the seasonal wind, our plant factor of this area is around 40%, around 50 to 40%. We can receive the highest, very good plant factor of the wind farm presently operating in this area. We have the large amount of wind power plant in Puttalam region, as well as the Mannar region, as well as the Jaffna Peninsula. Presently, we have not any large-scale wind turbines in Hambantota area, but our very first the pilot plant was installed in Hambantota, but that plant presently not operating. It's already removed. I think wind, considering wind potential, this is the thing what I can explain, because I didn't go deeply for a wind potential one. Actually, this is the, I think you can go this site here, the Global Wind Atlas. You can take any idea about that. Now, shall we discuss a little bit about the ocean energy potential in Sri Lanka? We have some sort of ocean energy, the wave energy one. You can see here, actually First, I'll explain that the tidal energy one. Wave energy is different point. There are two types of sources, tidal and wave energy. Wave energy is coming again that the wind, due to the wind, the wave is generating. That's the one point is there. However, the sea level is varied due to these two effects, tidal energy and wave energy. The tidal energy is due to actually the moon-earth correlation. Shall we think the moon is here? Actually, the moon is there. You can see here now the earth is rotating. The high tide is that there are two tides per day. It is in line with moon as well as the just opposite side of the moon because of the centrifugal force of the water is due to that the moon earth correlations and tide is coming there. Then actually, in the Sri Lanka, we have not much tide again. That also locational wise. There's a large amount of effect is there. There's ocean conditions and the land mass locations are all affected are there. We have not much tide compared to some other countries, but some countries they received very high tide, maybe the few maybe 10 meters, 15 meters tide also there. We have not that much. We maybe only few meters, maybe half a meter, that type of tides are there. Yes, how would personally, we have not any plan to harness tidal energy, but there are some potential for wave energy. Actually, this is also some sort of example, one explanation how that tide is generating. That tide generation, you can see here, the moon is there. You can see due to the centrifugal force of the water is coming towards that moon. If sometimes the sun also there, then we are calling there's a spring tides is there. Sun and moon is aligned with there. Then other things, neap side tides, that the sun is other way around, then the moon is other way around. There are the large tide we can observe in the spring tides compared to the neap tide. Then is a tide generate. Then a tide, so tidal energy can be generated. Similarly, you can see here, it should be some land area is required. Here or some lagoon type land area, water can be passed to some barrier. This is a current barrier. Then we can use generate some turbine generator, and the turbine can be generate power because of that. The current can be flow to both directions sometime because of the water come to the lagoon in the high tide, and the low tide it's released from lagoon to sea. Then that motion, the amount of water is the important one. The head, there's a tide head, and there's a amount of water is the important two parameter, how much of energy can be generated. Yes, there's a wave energy point is there. You can see here that also the tidal measurement throughout that Sri Lanka. I think you can, there are some theses I can found here. Then however, the potential wise, presently actually it's a commercial viable situation. Presently, there are no studies. Maybe some places we can generate some amount of energy, but still we are in research level. And the one concept we can see that octec also. Octec, we have some potential in Sri Lanka near the Trincomalee and some other places. The oceanal temperature difference also we can use to generate energy. Then that also one point here, but a small amount of power generation can be think about to generate some power. We need to find suitable the working fluid to operate that particular temperature difference. Then that's a temperature difference. Maybe the cold water with the 5 degrees and the surface water maybe 25 degrees. We can drive a cycle in between 25 to the 5 degrees or 16 degrees. there's a combined cycle we can operate. That's in between that. Then this type of technologies are also available. We can consider these all other renewable energy. But in the commercially viable things that we already explained, that solar and wind, presently we are commonly using in Sri Lanka, the biomass also. Today I'm not going to explain anything about the biomass. The biomass, solar and wind are the commonly used in Sri Lanka as a renewable energy. I think those are the main things what I can explain here. I think if you have any questions, we can discuss now. We have another around 20 minutes, I think so.
Uh, yes, I have a small. Uh, hello.
Yes, please ask your
Yeah.
question. No problem.
Yes. No, no. If, say, for example, now we talk about now these tides about what is the concept that due to this is happening due to the gravity of the moon. That means in case of the gravity of the moon is equal to the gravity of the earth, that means all the coastal area will be every day it will be flooded. Is it? Now, because the gravity of the moon is now like a 1/10 of gravity of Earth, if it is equal, that means we will experience. That means it is a serious issue in the Earth.
No. Yes. Shall I try to explain that again a little bit? Is the gravity that mean? Please wait. I'll go to that slide. Please wait a little bit. Actually, that's a motion wise. Shall I explain? Try to explain that. Shall we think now? And how can I draw this one? Right. Shall we think now? This is moon, huh? This is Earth. This is Earth. This is moon. Right. Now this is rotating. This moon and Earth both rotating around its center of gravity. This is the center of gravity, Earth and moon, roughly. This also, now this Earth is moving around this center of gravity. Now, what happened? There's some gravities. These are the two gravity point is there because of now the Earth is moving across that. Earth is moving around the center of gravity, and the moon also moving around this center of gravity. Now, what happened now here? So water is around there. There is a water is around this water. Now, due to the center of gravity, small amount of water is coming to that way, as well as the centrifugal force. this is the way. Shall I draw it again? If the Earth is circular, now water band is a little bit like that way. This is due to centrifugal force. This is due to gravitational force. That's the way the two tides are coming here. Then actually the gravitational force is Earth and Moon is equal for that rotation because that is a actually gravitational force is I can't remember that equation. Yeah, G is M some equation can remember R
Yeah,
plus
M1
and
M1
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 and
into M2 into
yes,
R1
yeah.
squared into R2 squared, something like
Yeah, yeah, that's the equation. This is the
that.
force applied to this water because of actually not only water. This all there's all Earth, but the this water has some the what is a liquid? It can be a little bit jump ahead. That's the reason is the tide is coming there, right? Because of the two tides are there in the one tide, it is due to that the earth moon gravity field. Other tide is due to that centrifugal force behind that, and these are the two tides are that's the reason per day there are two tides we can occur. For a tidal energy, it should be some the water lagoon type location should be there. Shall we have that Putlam lagoon? That's maybe a very good point because of the lagoon can be contain large amount of water. There's a one mouth we can observe here, but our tide situation is not much high. Maybe there are some potential, but we cannot utilize that. And this amount of water can be retained in some lagoon, then it can be used. Some countries, some locational wise, it is a very much site specific. We know that wind also site specific. Solar also actually solar we can receive throughout the country. That also is a very amount. There are some small site specific things are there. Hydro also very much site specific. Renewable energy, there's effect here. The tidal energy also highly site specific.
Yes, this is the generation of the energy by using these tides. When it is the low tides to up this upper one, and we are taking the water
Yes,
to the lagoon and the lagoon to
yes,
the sea. So this water
yes. Actually,
this
mhm,
mechanical, this flow is the kinetic energy, and we are converting into a mechanical energy. That is the
mm,
concept. The question what I ask,
yes,
this is something, little more into that one, the phenomena or the concept, the tides, it's happening due to this
mhm,
rotation of the earth and also the
mhm,
gravity of both the earth and the moon. And there
mhm.
in every time this distance between the moon and the earth is variation, since it
Yes,
is what is
that
that
was affected.
yeah, the
Yes,
moon, the earth
that
is,
was affected.
yes, that is actually the moon
Mm,
is not rotating on the exact circle.
mm, mm.
That distance is different. And
Yes,
also when it is come to closer to the earth, then we are getting the high
mhm,
tide. We are getting a high tide.
right,
When
right.
the distance is the far away from the earth, it is going the low
Mm,
tide. And
mm,
my question is, just as a, something different, if the gravity, now say for example the gravity of the earth is a 10 kilogram per meter square, something like that,
mhm,
Newton kilogram per meter square. Okay. And Now
Mm-hmm.
the gravity of the moon is, say, 1/10 of the gravity of the Earth. Normally we
Mm-hmm.
do this in calculation. It is the way we do. So my
Mm-hmm.
concept is, if the gravity of the Earth and the gravity of the moon is both are equal, when it is so,
Right.
in case, say for example, so that means the Earth always experience under, this, all this coastal area will be under, what is that, due to the high gravity of the moon. And when it is come to this closer to the Earth, in the rotation, that means we will experience in flood due to this high tide. It will happen.
Yeah. Yes, yes, that's the point here. There is a tide generation, but in Sri Lanka we have not that much high tide there. Then some countries I noticed that sometime they in daily they have 10-20 meters sea level variations. Especially some location in Scotland, they have the around 20-meter sea level variations they can observe twice per day. That's locational
Yes.
wise, because there's locational wise variations are there. But in Sri Lanka, we have not much that type of variations we cannot observe. Actually, this is the tide height is depend not only for moon and earth gravitational force, because other all effects are there. How much of water depth at that point that there are because of the sea depth, as well as the land topology, because of sea current variations, because of that water mass, because of the sea current. That is, there are other circulations we can observe in the sea also. This all effects we need to consider to understand what are the tide height for each and every locations. But we notice that we have some sort of tide height there, but but the sea level variation is not much high. That is in Sri Lanka. Maybe we can generate some amount of energy. There's a study already conducted somebody, how much of energy can be generated each and every location, because of each and every, actually energy mean how much of water can be stored in the high tide area. That water need to be released that low tide time. Then there's lagoon that means lagoon area and everything we need to consider to calculate amount of energy generation by tidal energy. As well as this depend amount of water and height of the tide. Both need to be considered. You are correct. Maybe
Yeah.
because of that, the flood may be not a big issue, because of that is already happening twice a day. They already adapted these places because of the locational wise. They already reserve that coastal area to accommodate that high water content. That's the point here. Actually, I can notice that. Then I have some experience some other country in the Germany. Actually, then I very first day there's some road is there. I travel by bicycle. When I don't know the tidal time, I cannot return back that road. I need to stay for another 2 hours time because of the road is flooded. That happening. There's a common. They know that road is flooded. The twice a day at that time, any vehicles cannot be passed to that road. That happens in some places. There's a
It's
common
normally
places.
this tides is it won't happen more in the equator area. That will be in the southern and north.
Yes, yeah, we cannot say that because of that centrifugal forces come in there, because amount of water depth as well as the sea currents. There's other lot of effects are there. If you
Okay.
consider that the centrifugal force and forces, that is correct. In Sri Lanka should be have the high tide. But in the
Yeah, sure.
other lot of effects are there, not only that point, maybe sea level and maybe other all things, maybe lagoon and sea currents and everything are there. We cannot, very much complex that. Just only one phenomenon we cannot predict that there's the level of the tide. Because of that, see the water, there's a water is around the world, not only gravity, due to other places are there. The all locations are there, especially sea current. and as well as the wave, the wind speeds, and a lot of things are there. Just phenomena is there, but empirically we need to measure the tide height each and every day. I think if you visit the Nara site, they may have that data. They have some the measurement point in Mattakulia. I know the Mattakulia. I don't know. They have some other measurement points in around the country. They have the time series data for the sea level variation throughout the day. We can observe the tidal variation very clearly. But we cannot assure that the equator areas we have the high tide. You can see the water changes when you go there. Shall I go to my previous slide again? I explained that you can see here when you go, shall we think in this location, right? I think my yes, you can see in this location, right?
Yes.
That location. You can see here, that location may be high tide because of that now the very low at that point, and because the water is already moved to that area. Now in a other period, it may fill up water. Actually, tide mean level difference. Tide
Yes.
mean level difference. Then level difference are happening not only the equator because of the water is flow from polar region to due to that. Then its level difference may be higher in this area compared to the equator because of the here is a low level. Maybe in this is the high level now, but in the at that period here may be high level. Right?
Yes, yes, yes. Understood you. In Sri Lanka, we have plenty of, the resources in the wind and solar, and why, the still our government is, not concentrating on that one. As you explained, this wind, this
Yes, yeah,
Atlas,
actually,
and we
yes.
have from Jaffna Point P to this Manabe, and we have, I think, much more, the enough wind resources is there. And if it is, not in the
Yes,
onshore, and why the government cannot go for this offshore for the long
yes,
run?
actually, the presently the cost of energy wise, I give very rough idea. From the offshore, it's double the cost compared to the land onshore, and the cost of energy for offshore is double the cost. Shall I give? Shall we think for onshore it is? Shall we think? Yes, maybe $0.05 per kilowatt hour. Just for idea, that may be not a correct value. That is double in the offshore. In this renewable energy one, we always think about the cost of energy again. Because of for a large scale point, we need to think about cost of energy. Other thing, the absorptive capacity also a very huge problem now. I give one point here that the curtailment issue is not only is the biggest issue in the world for the wind and solar. Very recently, I noticed that in the actually in the Scotland, now that Scotland is already 100% by the wind because of their all requirement they can fulfill by the wind energy. But they already connected to the main island there. That means is England. They connected to the main island. They export their energy to England. Now that England is not ready to absorb their all wind energy generation because of that some other grid absorption issue. Their curtailment, I noticed that their curtailment is higher than our total Sri Lankan requirement. Very huge curtailments there. That curtailment issue is coming throughout the world now. But in Sri Lanka presently, we have not any curtailment for the wind, I think so. But recently, I noticed that the solar, they have some issues there. They try to do some curtailment of the solar because of the absorption situation. But if you go for some the storage system, hydro pump hydro storage system, we can do some extent to absorb that type of renewable energy. Now the Sri Lanka have some plan is there that Mahawaya 600 megawatt hydro storage system. I hope if it will become soon, then we can absorb much more a high amount of solar and wind energy. That's the point here. Then other thing is the cost of energy and the tariff systems are very much different. This all the politics and all things come into there. But the technical wise, we need some storage system to absorb further wind and solar.
As I
That is
understand now, in many industries in Sri Lanka these days, they closed
Mhm.
down and moving out of the country. I think if we compare the last year and this
Yes,
year,
yes, that is
the consumption of the
yes,
electricity is reducing. This year is, I think, drastically reduced compared with this earlier, like 2020, 2021, something
yes,
like that. The reason is most of the industries are moving, and why we cannot give a idea or the proposal to the government. We have these solar issues also. This uh, we can encourage the industrialists to go for they utilize the
yes,
excess
yes,
solar to for these
yes,
issues. I think
yes.
here the
Yes,
CEB.
actually, for a industrial development, we need to supply energy for a low cost. That's the point here. That's the point in the actually now especially the Vietnam people and all those things. They consider that. There's a policy. I think actually I can explain this all. There's the policy wise things, but in my idea, if we give the low cost energy for industry, that is good for a country. There's a tariff, we can change that, some different tariff, but I don't know because of that. As a utility company, they need to balance their all cost balancing, everything's can come to there. They need to go some low cost power generations. That's the point here. But then we need to identify what are the low cost power generation sources, not only renewable energy. I cannot say renewable energy are the low cost power generation. We need to find out some other low cost power generation to fulfill our industrial requirement. But we need to do some the mix of energy generation, solar, wind, and other things should be mixed there. But we need to find out some other suitable low cost. Maybe there are different things are there. Other thing
Yeah,
we can do some tariff relief, especially for productions productions things. But presently, it may be not implemented in Sri Lanka. Hope we can maybe later, if that issues come in, then it should be government should give some special tariff for productions.
no,
That
we are we are lucky enough that the Iran and Israel war is not continued, is stopped. Otherwise, the Iran closed this Hormuz,
yes, yes,
the
that's
sea
I
area.
think that is
The Sri
that
Lanka is
that
a
effect will not
totally, totally
be
the Sri
blackout.
Lanka will be a blackout. So that means,
Yes, not only Sri Lanka.
when we are not, the talking about here, the cost of the
Mhm.
energy, we have to see the essential need of the energy in future. The Sri Lanka must go and utilize all these available natural resources. It is very, very
Yes,
important, I believe.
that is important. Mean that we are calling this a energy security.
Yes.
Presently, our energy security is very, very low level because of actually there are many reasons are there. No? Did you notice that some countries, especially in Europe, they develop there a lot of the wind energy because of they have some issues in last few years for a gas supply from Russia. Then for a energy security point of view, we need to consider there are energy sector, we have a lot of issues are there, but we cannot discuss in this type of forum these all issues and policies. That is totally separate the session. I don't like to extend this session up to the energy policies and these things. That is totally different, right?
Okay. Yes, it's understood.
There's some other there's a different story. The politics and the policies are different. Energy security, cost of energy, tariff systems are very different things are there. And we have to think that there is not only energy. We need to combine with the country economy and environment and a lot of things we have to consider. Different point of view. Then the fuel crisis, fuel increases, yes, then yes, these all things are there because of the energy security point of view. Actually, we need to consider some sort of energy security when think about the renewable energy. Yes, that is correct.
that is the main reason that most of the foreign investors are not rely on investing on Sri Lanka. And because I
Yes,
was
yes, that is
trying
correct.
to work out with some of the investors like Korean people from
Mhm.
2016, and we
Mhm.
find out that there is no energy security and there is no assurance that the continuous sustainable supply for the industrial sector. That is
Right.
very important, the drawback in Sri Lanka, that the factories operated already, they left out.
Right. Okay. Then there are some of the two questions I can explain a little bit about that. Is that the storage energy by the fuel cells? Yes, that option. Transportation also important. We can use there. I noticed that the plug-in hybrid, actually plug grid, grid to vehicle, grid to vehicle to grid concept. So some countries they are using there because of that off-peak time they can charge their batteries for vehicles. Then the peak time they can again resell their energy to grid. That concept also there. Some countries they presently they are using that. That also good options for a transport. There are a lot of technologies are there, and unfortunately we are not in the position to use all these technologies. We know that even though the technology is there in the Sri Lankan situation is not like that. We need to go to up to that level. This is the attempt to we have to go furthermore to all absorb all to solve all these things. I think somebody has some few questions. Now the time is 9:33. I can spend another 5 minutes more. Recent countries, not only Sri Lanka, but even the fuel crisis. Yes, these the all questions are a lot of the based on the policies and politics. And actually, some questions I cannot explain. I can say this should be the way, but why it not happening, we have not the answer for that. Actually, fortunately, there are some the good news is there now. They are the CB going to establish the pump hydro plant very soon. There's the Mahoya plant. The plan is already completed. This upper reservoir is Navalapitiya, lower reservoir is Aranayaka. I think around 300 like head meters are there. The capacity is 600 megawatt. Is a good capacity for Sri Lanka. If it will come, we can solve a lot of things. But it requires huge money. I don't know how that they're going to find that much of money to build that pump hydro. Yes, I think so. We can wind up the session today. No problem. If you have any further questions, please email me. I can answer. Shall I wind up the session today? Okay. Thank you very much for you all. Thank you.
Thank you.
Thank you, sir.